A serious issue has arisen in the field of astronomy due to the latest findings of the James Webb Telescope, which have illuminated previously unknown aspects of our universe. The continued discoveries made by this telescope are having a profound impact on our understanding of the cosmos. By casting its gaze into the remote past, the telescope has revealed secrets that were previously beyond our ability to perceive. A recent surprising discovery has challenged our fundamental understanding of the universe, indicating that we may be completely wrong about its size. In a recent paper, scientists have revealed that new images captured by the Webb telescope have identified objects that existed only 120 million years after the Big Bang. This not only challenges what was previously believed but also calls into question the foundations of the standard cosmological model. Astronomers admit they did not anticipate discovering something of this nature in the images captured by the Webb telescope. It appears that the universe is indeed old but not infinitely old, a revelation that has surprised many and refutes the idea that the universe must have an infinite age without a starting point. This discovery has shown that our intuition has been wrong most of the time. We now face the uncertainty of not knowing what else the universe has in store for us. Even when the Webb telescope looks as far out into space as possible, it only manages to observe a distance of about 46.5 billion light-years. This defines the Hubble radius, also known as the Hubble sphere, which marks the limit of what we can see from Earth. The most remote galaxy discovered so far, the JADES GSZ 13-0 galaxy, formerly misidentified as IES, was identified by the Webb telescope and lies within this region. Another record-breaking galaxy, Maisie's Galaxy, existed approximately 450 million years after the Big Bang and also lies within this Hubble sphere. While we know that our universe is expanding, what is even more intriguing is that this expansion is accelerating. As the universe expands, the Hubble sphere grows, allowing the visibility of objects that were previously beyond its boundaries. However, at the edges of this sphere, the expansion is happening faster than the speed of light. This means that although the Hubble sphere itself does not expand, when we observe extremely distant objects, the speed of expansion of space between us and those objects exceeds the speed at which light can reach us. Therefore, light from very distant stars and galaxies is moving away from us at a faster rate than it can reach due to the stretching of space between us and those distant objects, an effect caused by cosmic expansion. The Hubble sphere will eventually stop growing once it reaches the cosmic horizon, thus defining what is known as the observable universe, the maximum region of space we can see. The observable universe is like an imaginary sphere surrounding us with a diameter of approximately 93 billion light-years. This measurement represents the maximum distance at which we can see galaxies and stars. Light coming from within this sphere has traveled for billions of years to reach us. However, anything beyond this sphere remains invisible to us, even with the most powerful telescope imaginable, because the light from these objects has not yet reached us. This situation raises an intriguing question about the total size of the universe beyond the observable limit. In reality, we do not have a precise answer to this question. Although our current cosmological theories provide mathematical estimates, we still lack sufficient information to be certain. Some research suggests that the total universe could be at least 250 times larger than what we can observe. Other estimates suggest it could be as much as 10 carat 10 carat 10 carat 10 carat 10 carat 122 times larger than the observable universe, a number so immense that it is almost incomprehensible. Despite these estimates, the uniform distribution of matter in the universe and the uniform temperature of the cosmic microwave background suggest that the universe could be infinite in size. However, this remains a theoretical possibility rather than an absolute certainty. When we look at extremely far distances in space, we are actually observing events that occurred billions of years ago. The galaxies near the Hubble sphere are not galaxies as they exist today, but rather galaxies as they were billions of years ago, according to our standard cosmological model. According to this model, approximately 14 billion years ago, the observable universe and everything beyond it were concentrated into an extremely small point, which we call a singularity. However, if the universe were truly infinite, this notion of a singularity compressing into an infinitely small point would not hold. The evidence suggests that the universe is infinite, meaning it may have always existed without a singular beginning. This would imply that the Big Bang occurred everywhere, rather than at a single point, and that the first galaxies did not form in one specific place but all throughout the universe, even beyond what we can observe. This idea raises a profound question about the origin of the universe, a question that transcends science and enters the realm of philosophy. It is similar to the old steady-state model, which proposed that the universe has always existed without a beginning. This perspective was once supported by great minds such as Isaac Newton and Albert Einstein, who initially rejected the Big Bang theory. However, mathematical evidence eventually led Einstein to consider the possibility of a finite origin. Observations of the cosmic microwave background suggest that the singularity was not a single starting point but rather a state where all matter throughout the universe came into existence approximately 13.8 billion years ago. However, recent discoveries from the Webb telescope are now challenging this estimated age of the universe. Each deep image captured by the Webb telescope reveals unexpected surprises that force us to reconsider the conventional Big Bang model, which suggests our universe is approximately 13.8 billion years old. Until 2022, the most distant known galaxy was believed to be CERS 93316, but later studies revealed that it was actually a nearby galaxy that appeared more distant due to dust clouds. Recently, the Webb telescope discovered F200DB045, a high redshift galaxy candidate with a redshift value of Z is almost equal to 20.4, which corresponds to about 168 million years after the Big Bang. If confirmed, this would be one of the oldest and most distant galaxies ever observed. This discovery, although still needing further verification, may require a revision of the standard model to improve our estimate of the age of the universe. Additionally, massive galaxies have been discovered that seemingly formed just a few million years after the Big Bang, challenging our understanding of how quickly galaxies formed in the early universe. Another significant finding made with the Webb telescope is the detection of two black holes that existed 700 million years after the Big Bang. These discoveries suggest that the universe may be much older than previously thought or, possibly, that it had no absolute beginning and has always existed. These revelations raise the possibility that the universe, seemingly infinite in size, may also be infinite in age. The Big Bang could have been just one event in the evolution of this universe, rather than a true beginning. However, further research will be needed to determine whether the idea of an eternal universe aligns with our current scientific theories and whether it can effectively explain the unfolding of events following the Big Bang. This concludes the discussion on the current crisis in cosmology. Feel free to share your thoughts in the comments section, remember to like and subscribe, and I'll see you in the next one. Thank you so much for watching.